Okay, I want to explore limits again using algebraic techniques, this time involving complex fractions. Algebraic limits with respect to complex fractions. So let's say we want to take the limit as x approaches 4 of 1 over x minus 1 over 4 over x minus 4. Okay, so this is what we call a complex fraction. There are fractions within the fraction. And the first thing you try is, well, let's just try direct substitution. Let's try to plug in 4 for all the x's. On the top, we get 1/4 minus 1/4, which is 0. And on bottom, we get 4 minus 4, which is also 0. So we have 0 divided by 0, which is not defined. Okay? So what we're going to do is try to take the complex fraction and algebraically manipulate it so that we're not dividing by 0 when we do direct substitution. So we're going to simplify the complex fraction. Now there's a couple ways to do that. I'm going to take the quicker approach. This is a calculus video, not a basic algebra video. But in a more basic algebra class, you might try to get a common denominator between these two fractions and put them together and go that route. But instead, what we're going to do is we're going to multiply the whole fraction by this red fraction is going to equal 1. When you multiply by 1, you don't change the value of what you started with. So whatever I multiply by here, I have to do the same on the top and the bottom so that this red fraction equals 1. Now the goal of what I multiply by is to get rid of these little denominators here, because those are what are forcing this to be a complex fraction. If those weren't there, we wouldn't have a complex fraction. So what could cancel x and what could simultaneously cancel 4? Well, how about 4 times x? So let's multiply the big fraction by 4x over 4x. Notice I'm lining up my fraction bars here because this 4x is going to multiply by everything on the top, and this 4x is going to multiply by what's on the bottom. And also notice that this equals 1, okay? So what we get is the limit, and on the top, remember I'm trying to fix the top. There's where the problem is. So I have to distribute my 4x to the first fraction and to the second fraction. When I multiply 1 over x by 4x, the x's cancel, and all that's left is 1 times 4. Minus, when I multiply 1 over 4 by 4x, the 4's cancel, leaving 1 times x. Now on the bottom, I'm not going to distribute, okay? The reason for that is I'm not trying to correct anything on the bottom. I don't have any fractions here. So I'm just going to rewrite it the standard way. I'll put my 4x in front times my x minus 4 without distributing. You could distribute, but you're going to see soon why it would be better not to. So what we have is the limit of, well, that's 4 minus x over 4x times x minus 4. And we're taking the limit as x approaches 4. Okay? So at least it's not a complex fraction. However, this did not help us yet, because still, if we plug in 4 for x, if we do direct substitution, 4 minus 4 is 0, and 0 times whatever this is 0, and we can't divide by 0. So what's going on here? Well, the good news is that 4 minus x and x minus 4 are almost the same thing. So what we're going to do is we're going to take them and make them the same. So I'm going to take this guy, and I'm going to factor out a -1, right? I'm going to factor out a -1. When I do that, both of these signs are going to change, and it's going to match x minus 4. So I'll show you what that looks like. So if I pull a -1 out of a positive 4, that gives me -4. If I pull a -1 out of negative x, I get a positive x. Okay? So let me recopy everything else. So we've got the limit of that over 4x times x minus 4. Now, -4 plus x is the same thing as x minus 4. So now what I can do is I can cancel those, And all that remains is the limit as x approaches 4 of -1 over 4x. And now, if I try direct substitution, because I've gotten rid of the problem child, this x minus 4 in the denominator, now I can do direct substitution, and I get -1 over 4 times 4, which is -1/16. So the limit as x approaches 4 of this original complex fraction is -1/16, and we did that through a means of algebraic manipulation.